Alrighty, here we go. Now, we've been doing a bunch of stuff with probability. You've been doing great because I think it's pretty, I don't know, it's just intuitive for you, and I think you get the idea. And so what I want you to do is you have to make sure you have these three things: something to write with, calculator for sure, and then open up your textbook to the beginning of section 12.3, which looks to be page 381. All right. So while I get my stuff ready, you get your stuff ready. If you need to pause the video, go ahead and do that. So we're ready to rock and roll. Okay. Today, what we're going to talk about is finding experimental probability of compound events. Okay. Compound. So let's take a look at what they mean by a compound event. What they're talking about basically is when you have two events happening together and you're considering them together. Okay. Two or more is the way they define it. And actually, when we did our probability stations just the other day, I had you do one of these, and this is where you, exactly this one, you flipped a coin and rolled a die, and then you had to come up with all your possibilities. So when we're taking a compound event, you're doing each of these events. So when you talk about flipping a coin, either you can get heads or you can get tails. So there's only two possible outcomes there. When you're rolling a die, you have the possibilities of 1, 2, 3, 4, 5, and 6 on a standard kind of die. There's a total of 6 different ways that can happen. So when we take into account both of these things together, this is what I had kind of listed out on your options as you performed this particular experiment. You could have heads and get any one of those 6 numbers. So they just shortened it up by doing H1, H2, H3 through H6. Or if you flipped your coin and you got tails, then you combine that with a die roll of 1, 2, 3, 4, 5, or 6. So when you take into account all of those situations or combos, take 2 times 6 and you end up with 12 possible outcomes. Okay. Now, we already did this experiment and I had you actually go ahead and calculate that one. So if you lay it out all nice and neatly in a table, then you can kind of see how many outcomes you've got. And when you perform your experiment, then you can just draw from that data and write the fraction to calculate what your experimental probability is. Okay. Next module, we'll get into theoretical probabilities and what it should be. With right now, our experiments will kind of define what's happening. All right, turn the page. Here they've got one laid out for you. So imagine that you are going to some chicken joint, whatever that may be, and you have your choices of either the 2-piece or the 3-piece dinner. With each of those, you get a choice of a side, and you might have a salad, mac and cheese, French fries, or coleslaw. So you got 4 different side options. You have 2 different sizes for your chicken. 2 times 4 gives you 8 possible combinations there or specific outcomes. And then what they did is they decided to record at this food truck what all of their orders were for a particular day and compiled that. So if I was going to ask you any questions about an experimental probability, such as they're doing here, what's the experimental probability that the next order is a 3-piece chicken with a side of coleslaw? You're going to focus in on this number here, 3-piece and coleslaw, and you know that that's 55. And then basically you have to go through and generate, all right, 55 out of how many? That's your total outcome. So what you have to do is grab that number and add those together, and you end up with this fraction, 55 orders out of a total of 330. Go ahead and simplify that fraction in simplest form. This one actually works out to be pretty cool because 55 over 330 is exactly 1/6. Don't believe me? Check it on your calculator. All right. All right, so let's take a moment and let you do one. What I'm going to have you do is go ahead, pause the video. I want you to go through this one and then check with your neighbors around you by your tables and see if you end up with the same thing. When you resume the video, then you'll be able to check your answer. All right. Drink sales for the school carnival. And they're saying, what's the experimental probability that the next drink is a small cocoa? So you look at small cocoa and you know that you get 60, and then you better grab your calculator and total up all of these possibilities here that are listed in the chart. All right. So as you do that, and I'm grabbing these numbers as quickly as I can. 52, is that 52? I believe so. You get a total of 400 possibilities. 60 of those were the cocoa. Get that in simplest form. As I do this, because I'm old school, divide by 10 on the numerator and denominator, or factor that out, you get 6/40. That's the same as 3/20. I'm good if you leave it as a fraction. It didn't specify in this particular question if they wanted fraction, decimal, or percent. So depending on your preference, you could just leave it as 3/20. If you want to write that as 1500ths, that's cool. If you want to write that as a percent, you can do that as well. Okay? Awesome. So really, it's very similar to what you've been doing before. You're just picking out the information that will help you calculate this experimental probability. Okay? Now, sometimes they might ask you to pick a simulation that you could use. So, for example, here's what they're talking about. The scenario is this, that you either have a car or a truck. Okay, you have a certain vehicle. So as you look at the table, jump ahead here. You have two choices here, a car or a truck. And then at the intersection, that vehicle may actually turn left, it may turn right, or it may proceed straight through the intersection. So here's where these three choices come in. That gives you two choices and three choices. It gives you a total of 6 different outcomes. Okay. Now, what you could choose to model all of that data would possibly be something that gave you 6 possible outcomes that are equally likely to occur. When I see 6, I'm thinking of rolling a die, but you certainly could also end up using something like a coin toss and then this particular spinner, which has 3 sections. All right. Why you would make it that complicated, seriously, I don't know. But it's just another way to simulate a situation that has a total of 6 outcomes. One of them has 2 different choices, one of them has 3. So you could choose a compound activity to make that prediction. All right. Basically, what I want you to do is let's start diving in. So on page 384, at the top, there is this your turn problem. And what I would like you to do is pause the video, take a moment, read through it, look at the information that you are given via this particular simulation, and then answer the question that they have up there. Okay? Okay. Back with me? Here we go. So you have your choices of silver and gold, and then different lengths of this particular necklace or chain. So they want to find what is the probability that the next necklace sold is 20 inches and it's gold. That would be 12. out of the total, and the total that you have there is 75 once you total everything up, all right? When you simplify this, you should end up with the fraction 4/25. If you turn that into a decimal, I believe that should give you 16/100ths, and as a percent, it's 16%. Okay, that's still pretty low. All right, 16%, but it's out there. Okay, just kind of keep you going through this. All right, what I'm going to assign you to do, and even though there's a lot of words in these situations and scenarios for each problem, really it's very straightforward if you just take the patience to read through the question. All right, so for example, on number 1, it says the dentist has 400 male and female patients that range in ages from 10 to 50. So you can kind of see how they've broken this into categories by age and then by male and female. So you have 2 choices here. You have 4 categories up there. That gives you 8 different possibilities. Okay. Now, I've gone and checked this already, but they do give you the total already out of all 8 of these to add these up. So I know that my total possible outcomes is 400, and I can put that in the denominator. Now, when it says, what's the experimental probability that the next patient will be female and in the age range of 22 to 39? That's 50 choices or 50 possibilities out of a total of 400. Grab that fraction. Please write that in simplest form. Pretty much any time you get a fraction that's not in simplest form, rewrite it that way, okay? Final answer should be 1/8. You may leave it that way if you want to turn it into the decimal 125 thousandths. That's fine. That's also equivalent to 12.5%. Okay? Boom. There you go. All right, your assignment is you take a look here. You've got a couple questions on page 384. And then on the following page, you have each of these. Sometimes they give you a table of data and then ask you multiple questions. And I would like you to basically go through, I think, all of these, even these higher order thinking questions. You can get through that pretty straightforward, I believe. So here's what I want you to do. So page 384 to page 386. And let's do this. Ta-da. Let's have you go 1 through 11. Okay? So we'll probably talk about the rest of these in class and what they're asking you to discern there. All right? So this much in the textbook. When you get one done with that, I want you to head into iExcel and focus on those ones that I've highlighted on your checklist for getting ready for MCAs. All right? So page 384 to 386 and iExcel. As always, work hard and may the force be with you.